Aloha and welcome to this module on version control and configuration management. Now, as you might be anticipating, I'm going to tell you that this is one of the most important modules of the entire semester, and you're right, it is. It's yet another one of the most important modules this semester, and I know I've said it before, and I'm saying it again, but this time I truly mean it. Here's the deal. To do professional software development, unlike development in a classroom, you almost always have to evolve the software over time. Software in the real world is like an organic, living entity. It requires energy. It requires feeding, nurturing, teaching, all sorts of things, okay? It's not static. The problem with learning how to program in an academic environment, well, one of the advantages of learning to program in an academic environment is that you build a software system, you get it to work, you turn it in, and you move on to something else. That's good from a teaching perspective. It just doesn't reflect what happens in the real world, where getting the software to its initial release is just the very beginning of its lifespan. Okay, that's the beginning, not the end. In the classroom, that's the end of times, right, for your software. You never want to see the darn thing again. You're sick of it. In the real world, once it's actually got to 1.0 and it's usable, that's when its life really starts. Okay? So this module is concerned with this issue of how is it that one can actually manage this complexity of having a living, organic system that requires changes, that requires adaptation, that requires evolution in response to changes in its environment. Okay? So, we want to understand the motivation. We want to understand why we need to think about configurations and why we need to manage them over time. We also want to learn how to use a particular form of configuration management system. The one we're going to choose in this class is called Subversion. I would venture to guess, in my experience, it's probably right now the most commonly used configuration management system. I don't know. There's some other ones there's some historical ones that may still be used more for historical reasons. There's some new ones like Git that I don't think have overtaken it, and then there's some proprietary ones like ClearCase, and they might be used quite a bit too. But if you learn Subversion, you can't go wrong, because it's a good system, teaches you all the fundamentals of configuration management, version control, and once you understand Subversion and the concepts behind it and the ways to work with it, then moving to any other configuration management system is much simpler. Could be very simple depending upon how close it is to the Subversion model. Okay? And then we want you to be able to use a Subversion client in your own project. Okay, so as I said before, things are going to evolve over time, and what makes that complicated is that software tends to be complicated structurally. It tends to be made up of a combination of modules, quite frequently in multiple languages. Think of your typical web application that might have some code in PHP, it might have some code in JavaScript, might have some quote-unquote code in HTML. Right there's three different languages that are involved in a common web. Oh, and then you've got some back-end database system that where you're emitting SQL commands. So that's four different languages that I can think of without even struggling at all. And we may want to take this same software system and deploy it in different ways to solve different kinds of problems, and we may want to build upon one or more libraries. Okay? So all in all, when you think of libraries, like the Robocode library, for example, is a library that we're using for our development. And if you imagine working on a robot over the course of a year, that robot will probably be used over the course of 3 or 4 different releases of the Robocode software library. So you have to kind of deal with the fact that the infrastructure underneath you is changing. And that's not even to say that maybe Java is coming out with new releases, Windows is coming out with new releases. Okay, so lots of things are changing over time, and it's almost like when you do stuff in the classroom, you work on something for just, like a few weeks or days, and it gives you the sense that in fact there's this, stability and stasis in the software world. But in reality, when you work on things over long periods of time, my last project I worked on it for 10 years, okay? The same software system for 10 years. And during that time, so many things, so many new developments came out with respect to operating systems, with respect to languages, with respect to toolkits, libraries. Things change. And when you look at a software system on that time frame, you feel like it's just extremely dynamic. Not only the stuff that you're trying to build, but everything underneath you is changing as well. So that can be exciting, okay? It can be great in many ways because there's new tools coming out that provide new facilities. Things that used to be complicated can get simple, okay? So if you can kind of surf that wave of technological innovation in a graceful way, then your software can get better and better and better over time. On the other hand, if you don't understand how to deal with it, then your software will break and you won't be able to figure out how to get it fixed again, and you'll be tied to some old release of something that becomes more and more obsolete, and you get dragged under by the dynamic environment of the modern technological world. Okay? So here's the kinds of problems that people often have. It was working fine yesterday. What happened? Okay, I've actually been seeing this a little bit on the news group. It's like it was just working. Now it's not. What the heck happened? Or you have a system, you give it to your buddy can't get the bug to occur that you're having. Then an even more insidious thing, you haven't probably experienced this yet, probably, but once you're working in a group, you could fix a bug and then potentially see that same bug reappear later on, a couple weeks later. All of a sudden it's back in the code for some reason you don't understand. And then finally, you might have the situation of wondering, I wonder if that bug that I fixed is fixed in this version or copy of the code. Okay, so if any of these things happen, you're really dealing with a configuration management issue as well as a technical issue with respect to the actual defect that's occurring. There's kind of two levels of problems. Okay? So configuration management is the process by which you try to define all of the different elements of a system and track their changes over time in such a way that when a problem occurs, you can immediately check to see which module out of all the different kinds of, or which element I should say, out of all the different elements that could have changed, actually changed at the point that that problem manifested itself in the system. Okay, and that can bring you a long ways to being able to solve the problem if you actually know where it is, what region of the system the actual change occurred that created this new problem. Version control is a more simple thing where it's just we're trying to deal with multiple versions of a system, and then defect tracking systems are systems that we kind of layer on top of a configuration management system so that it enables us in a systematic way to deal with whatever problem occurs and connect it to the particular versions of the system. Okay, so there's three classic problems in configuration management. Okay, first thing is the double maintenance problem, and that occurs whenever you find that you've got two files with the same code in separate places, and whenever you make a change to one, you need to make a change to the other one. It's called the double maintenance problem. Okay, and if you ever have the double maintenance problem, you've got a configuration management problem. Second problem in configuration management is the shared data problem. That's the fact that we have to allow multiple people to work on the same file. Not necessarily at the same time, but we can't simply, say, okay, developer A, you've got file B or file foo, and no one else can ever edit that file but you. Okay? We need to be able to share data and files amongst different developers. The third problem is called the simultaneous update problem, more colloquially known as clobbering, and that's when two people are editing the code at the same time, and then they, when they save their changes in some sense of save, only one of those developers' changes actually survives the edit. The second developer has clobbered the changes of the first developer. Okay? So those are the things that in any kind of configuration management situation you want to be able to deal with. So how are we going to deal with them? Well, let's clarify some terminology first. The first is that what we want to talk about is, as files, they always exist in multiple versions as they get, edited over time. And so you can see here we have, we have a foo.java, and it gets edited, and then the same version of foo.java 1.2 version gets edited in two different ways, and we get two other kinds of, now we kind of have a parallel set of course of development for foo.java, and then eventually the changes from these two versions of foo.java at 1.4 and 1.2.2 are eventually merged to create now a new version, single version of foo.java called 1.5. Okay, and then you can see bar.java, it just simply goes through, three versions, and there's no forking of the file. Okay, configurations are basically sets of different files that form, a semantically meaningful unit. So for example, configuration 1.0.0 of this system, consisting of foo and bar, is the configuration consisting of version 1.1 of foo.java and 1.1 of bar. Then we've got a configuration 1.0.1 with these two files, and a third configuration consisting of these two files. Okay? And we can have different configurations for all sorts of different reasons. We can have it so that it can run on different platforms, or serve different customers, or enable different pricing levels, whatever, or simply just reflect the most fully functional, stable version of the system at any point in time, which is kind of the most popular way that it's used. Okay, so a version control system at its very least is going to allow you to represent multiple versions of a file. So if we have this file foo.java, a version control system will enable us to represent each of these different versions. 1, 2, 3, 4, 5, 7 different versions of foo.java. The version control system should be able to enable us to get to any one of these 7 different versions of foo.java. Okay, this is unlike your conventional file system where you only get access to the most recent version. The other ones are gone in some sense. You can look them up in maybe Time Machine or some backup system, which is in a very crude way a version control system. But we want more fine-grained control. We want to in a sense be able to explicitly represent when we want our versions, and have efficient ways to go back and forth. We also want some kind of locking, generally to prevent two people from modifying this file at the same time. That's going to avoid clobbering. And we want to be able to get back to any version of a file. Now, the way that's commonly done, interestingly enough, is via deltas. You don't want to store a complete copy of each of these versions, because only maybe a small portion of the file, in general, only a small portion of the file will have changed between any two versions. So this, foo.java might be 300 lines, and then you make changes to 10 of those lines, and you get the next version. So what you'd ideally like to do is just save a representation of that delta, those 10 lines that are different between those two versions, rather than making a copy of the 300 line file every single time. Okay? And there's good algorithms to do that. And interestingly, the way they do it is a little counterintuitive, although not really once you think about it. But what generally you do is you use backward deltas. And what that means is that at any one time, the system is going to store the entire text of the most recent version. So like version 1.5, because basically that's the version that 99% of the time you really want. Okay? And then what it does is it stores a set of deltas that enables from 1.5 to recreate what 1.4 was. And in this case 1.2.2. And then from 1.4 there's another set of deltas that enable you to reconstruct what 1.3 was. Okay? What this means is that it's very fast to get the most recent version, because you've got that stored in its entirety. It's very slow to get back to version 1.1 because you've got to do this chain set of deltas, but who cares? Because, it's going to be once in a blue moon that you actually want that version 1.1, or even less than once in a blue moon. You probably never will want it, okay? But just in case you do want it, it's possible to get there with, some effort. Okay, so the classic version control system is called RCS and has a lot of important concepts that have survived, since then. And you don't need to know too much about RCS except what I just showed in the previous slide. You can take a file, you can put it under RCS control. There's kind of a directory called RCS that's created with these RCS files, which have this (v) at the end, that represent both the most recent version of the file and all of its backward deltas. And then you can do various things. Here's the home page. You can check out or check in a file CI, which creates this foo.java, v file that will store all the versioning information. And if you really want to edit, once you've checked something in for version control, you have to actually check it out in order to edit it, and checking it out means obtaining a lock on it, which disables or prevents anybody else from being able to modify it while you're fooling with it. Okay? And then there's some merging and differencing and so forth. Okay? So RCS is, when we look at these three configuration management problems, it solves the double maintenance problem by saying there's this master repository where each file is kept on the file system. Different developers can get access to any file on the system simply by going to that directory and checking out the file. And it solves the simultaneous update problem, and it prevents clobbering by saying that each developer must obtain a lock on the file before they're able to do any editing. And what happens is RCS essentially changes file permissions. Okay, it's an open source system, easy to install, provides only version control, so there's no sense of a configuration of files. There's just a sense of there's this individual files that go through different versions. Problems with it, and this is, it's more of a historical system at this point. You're not probably going to ever want to use RCS, I don't think, unless you're somehow in some Paleolithic development shop. You got to be on the same file system, and I think the one thing back in the day when I was using RCS, the thing that really got to me is this sense of what we now term pessimistic locking, which is in order to do any editing, you got to get a lock and disable anybody else from accessing it. And the problem with that is that, being human, we often forget to release the lock when we're done editing, and that leads to other people on the team being bummed out because they want to do some editing, and you've got the lock on the file, so they have to send you an email, and blah blah blah. And there are these kind of ways to break the lock in RCS, which people end up doing, but then that kind of defeats the purpose of the lock, right? So anyway, so the next stage in the evolution of configuration management systems is called CVS. And what CVS did was take RCS and say, well, let's do a couple things. One is we're going to make it a client-server architecture so that you can use the internet to check in and check things out, and we'll make a local copy of the system on your workstation. Okay, and then there's some other machine someplace that has kind of the golden version. So not everybody has to be logged into the same file system in order to do things. The huge thing they did was, being totally fed up with pessimistic locking. They said, this is crazy. The amount of times that you actually clobber somebody else is, so rare. And normally you just have kind of social conventions in place. You know that Joe is working over on this version, on this part of the system right now. So you ask him before you go in there and start editing files willy-nilly. Okay, so really, the conflicts occur. It's not that they never occur, but they just occur very rarely. Okay, and so instead of having pessimistic locking, CVS came up with this very great notion, which is called optimistic locking. And the idea of optimistic locking is that you're going to now allow two people to modify the same file simultaneously. And whenever you try to check in your changes, the system's going to detect whether whether someone has modified that file since the last time you checked it out. Okay? Because if that has happened, you're basically checking in a version that doesn't include that person's changes, and clobbering can occur. And so what CVS says is, it looks like there may be clobbering about to occur, so I won't let you check it in. Go contact the guy that committed a change between the time that you last checked out the version of the file. Resolve the problems and take care of it that way. Okay, and so that's that's a much friendlier way and reduces a lot of the problems that occurred with RCS. Plus, it's client server, which is makes life much more convenient. Here's the version of CVS again. Pretty mostly of historical interest. For this, it's harder to set up because you have to have an administrator who sets up a CVS server, creates accounts, creates passwords. Now you have to configure your workstation, with a CVS client, and so the development cycle involves checking out a copy of the system to your computer, editing the files, trying to commit your changes, addressing these merge conflicts, which is when two people have edited the same file whenever they occur, and then updating your local tree when you believe somebody else has made changes in order to make sure you've always got the latest version of the system. And then they've got this idea of tagging a set of files to create a configuration, kind of a primitive kind of configuration, but a configuration nonetheless. So let's look at how CVS solves the three CM problems. Double maintenance problem, okay, it's solved because CVS uses a centralized repository that has the master copy of each file in it. Okay, even though local developers have their own kind of copies of the files, they aren't really viewed as permanent parts of the system until they're committed. We deal with a shared data problem because multiple developers can create local copies and they can check out the entire system. There's no locking. Okay, the simultaneous update problem is solved not by locking and preventing two people from editing at the same time, but simply by detecting when two people try to commit this modified versions of the same version of the file, and then saying, okay, you guys have to resolve your differences. Okay, so up until 5-6 years ago, CVS had been kind of the industry standard for open source with a centralized server. It was kind of complicated to install, and there were security issues because it wasn't really designed with security in mind. It provided both version control and configuration management, but wasn't an entire kind of solution to the development problem. There's other tools that are needed, and it had this idea of optimistic locking. Excuse me. Okay, so now let's turn to Subversion. And the team behind Subversion said, look, CVS, it's really pretty good. We really like it a lot. There's just a few problems, a few bogus design decisions that they made. No fault of theirs because everybody makes design decisions, but in the case of CVS, these design, errors got codified in the architecture and really can't be easily fixed. We really should kind of start over, taking the same core concepts and build a new kind of configuration management system, which shares a lot of the same concepts as CVS, but just does things a little better. So that's why they call it the compelling replacement for CVS. And you get the exact same ideas: checking out, committing, optimistic locking as CVS. The big difference is, instead of having RCS as the back end of the system, which was this kind of file-based thing, has a Berkeley DB, a fast database system. And then instead of having versions associated with each file, instead we're going to basically think of a version as a snapshot of the entire repository at any one point in time. And that can have some conceptual changes associated with it. You can attach a bunch of different kinds of metadata that allows you to do more sophisticated kind of things. You can have tags and branches, cheap copying, and so forth. So there's the URL for it. Here's what The homepage looks for it. It's now an Apache project as of about a year ago or so. Okay, versus CVS, Subversion is basically better in every way. It's got faster. It's got transactional commits. That's super important. I remember one time I was committing something like 500 or 600 different files for quite a large system I was working on, and I actually my batteries ran out on my laptop during the commit. And fortunately I was using Subversion, so that when my batteries ran out, the commit was just canceled. None of my changes actually made it into the repository, so I could just try it again the next day when I had my power cord associated. With Subversion, with CVS, it would have been a complete nightmare to figure out where it was that things died and do the right thing. Okay, this I think is most popular configuration management system in the open source world right now. But Git is gaining fast. I must say, Git has a lot of kind of mind share right now in the community. So let's turn to Git. This is a very interesting alternative to the Subversion and CVS models for configuration management. Instead of having this centralized repository where kind of the golden version of the code exists, Git says that's just crazy. We don't need that. We don't want that. That just gets in the way. So instead, everybody's going to have their own version, their own complete repository on their local system with every different version, and everybody can work on their own version of the system, and then basically people share by what's called pulling little bits and pieces from other people's repositories. And this is actually well suited and is an outgrowth of the development style for the Linux operating system, where you had a bunch of different developers and working on the operating system, adding little things, and they wanted to make arbitrary changes, and kind of people would experiment with different things for quite a while, and then you could essentially use anybody's variant of Linux that you wanted, although there was kind of the Linus Torvalds version, which was kind of accepted to be the the gold standard version that most people would use if they wanted something that was fairly stable and reliable. Okay, there's a great talk on YouTube about Git where Linus Torvalds essentially trashes not only the Subversion repository system, but also those who use it as being basically morons. It's pretty scatological and very quite entertaining and interesting. I don't believe, since I use Subversion, I use Git also, but I do use Subversion. I don't believe that I think he's kind of trying to go out and just make a point and add some humor. In particular, Git is a version control system where if you use it incorrectly, I believe it really enables your development process to degenerate into chaos, with every developer doing whatever it is they want to do, and there being no kind of canonical version of the system which is reliable and relatively bug-free and so forth. So it does give you quite a bit more rope. I think in many situations that can be very helpful or even necessary. I don't actually believe that Git is the best version control system for every particular scenario. Now, it's not to say that you can't use Git as if there was a centralized kind of golden version of the system, and many people do it that way. Okay, but if you're going to use Git that way, then you might as well be using Subversion, because you've essentially voluntarily decided to not use the very features of Git which was motivation for its development, and for not using Subversion or a centralized version control system. Anyway, so here's the homepage for Git. So Git is while Subversion was faster than CVS, Git is quite a bit faster than Subversion. The files are compressed and use less storage. There's no need for kind of a czar, someone who kind of manages the centralized repository and decides how that's going to work. You have a lot more different possible workflows with a distributed version control system than a centralized workstation, centralized configuration management system. And I'd say kind of complementary things, are advantages of Subversion. In many cases, particularly I think for many of you who are just at the first stages of learning how to collaborate in the process of software development, I actually think that you'll find a centralized version of the system where there is a place where you can get the latest, greatest version of the system. You'll find that to be, comforting and a simplifying assumption for the way that you do development that just helps you make forward progress. Okay, so I don't think ZARs are always bad. There's some other configuration management alternatives out there: Bazaar, BitKeeper, ClearCase, Visual SourceSafe. Definitely take a look at them. Conceptually, they tend to be, just minor variants of either this centralized scheme, of which Subversion is a canonical example, or distributed configuration management, of which Git is the canonical version. All right, thanks a lot, and I'll talk to you soon.